This video will review some of the fundamental basic wall creation concepts, including location line, wall function priority in compound walls, and how to attach the top constraint of a wall to a floor. To start, what we'll do is we'll activate the wall command. For this project, we're going to use the interior 4 7/8 partition for all of our interior walls. And what I'll do is I'm going to use the wall center line, location line, because I want the walls to be centered on the grids and the reference planes that are already in place. I'll start by creating a wall that runs down grid line 2, and then I'll draw it around grid line B, and then down the reference plane. Adding walls to create rooms on the south side and the north side of the building. And then adding a couple walls in here to create a stairwell and a place for bathrooms that'll be drawn in the future. I'm going to add a couple dimensions so that I could locate these walls precisely. And then using a combination of the split tool and trim extend to corner, I can create what's close to my final layout. The last couple walls I'll draw will be to divide this up into smaller offices. And then I can easily use the mirror pick axis tool to create a series of offices on the south side. And then I can use it again to create my second stairwell on the east side of the building. The wall type that we used is a compound wall, interior 4 7/8 partition. If we were to look at the structure of this wall within the type properties, you can see that it's made up of 3 different layers, a finish on either side, with a metal stud structural layer. The function that's given is an important item and should not be overlooked, because if I were to change some of these layer priorities here, the way that it joins into other walls is going to change and it could look different. For instance, if my exterior wall, which this is brick on metal stud here, if this had different priorities, say the metal stud was not the structural layer or one of these other ones was, then we would end up with some of our finish layers going through to join with the other side, leaving us with a graphic situation that we're not trying to achieve. Another item that's important to keep in mind is the location line we chose. So in this case, if I wanted to maintain a distance for my stairwell of 9 feet, then what I'd want to do is set that location line to be finish face exterior, since this is what is being defined as the exterior side, so that anytime I go in and change this wall type to something larger, you can see that this dimension is going to stay the same no matter what. Always going to be 9 feet because I set the location line to finish face exterior. Now if we go in and take a look at our level 2 floor plan, you can see that all the walls are ghosted in. And further, if I were to look at this in 3D, you can actually see all of these walls are actually protruding through the floor. So if I were to take a section and just quickly draw one through, you can see the walls are not terminating at the bottom of the floor, but instead are going all the way up to the top constraint, which is level 2. What I could do is I could use the select all instances in entire project, since those are the walls that we just drew. and I can use the attach top option and select my floor at level 2, and they'll all immediately be dropped down to the bottom of the floor at level 2. The reason this one didn't go is because it was part of a different wall type, and when I use the select all instances in entire project, this wall is not an instance of the interior 4 7/8 inch partition type. In this lesson, we are going to explore the skills needed to model a simple office building, starting with creating exterior walls using the stacked wall system family, and changing the shape of the wall using the Edit Profile tool. Stacked walls are a system family that allows the user to combine 2 or more basic wall types to create one wall with at least 2 subwalls stacked on each other. Stacked walls can be created from the Wall tool, and it's simply just a type that we pick from the type selector. To start, we're going to go ahead and edit type and take a look at what creates this wall. To further refine this, we want to make sure that we have the section preview mode set, and we'll go into edit under structure. By default, the stacked wall has 2 different types loaded in, and it's going to start off by giving us a base height for number 2 in our layers here. You can see as I select the different options, it's going to highlight which layer is which. And for this project, we're going to go ahead and set the brick on metal stud as our base layer, and we'll set our ephes on metal stud as our top layer. For our base, we're going to set this to 2'8". And our offset, which is going to allow us to align the walls into different locations, we're going to set to finish face interior, because we want to make sure that this interior face is always aligned. The way the 2 walls align, we're given pretty much our basic location line settings here. So if I were to change it to something like finish face exterior, you can see now it's going to align the exterior face but leave a jog on the interior. We're going to leave it at finish face interior. I'm going to hit OK until I get out of the dialog box, and then we're going to draw our wall. For this project, I'm going to use the rectangle draw method. I want to make sure my location line is set to finish face exterior, and I'm going to set my top constraint to top of parapet. And I'll make sure my offset is not set to anything, but set to 0 here. Using that rectangle draw method, I'm going to go from the top left corner to the bottom right, making sure that it's hitting that edge of slab like we had defined. I'm going to go to my default 3D view to take a look at the wall we've created. You can see here that we have that base of brick across the bottom of the building, and then we have the ephes finish above that. Our next step, we're going to go ahead and use Edit Profile to create a notch here to define our entryway. To do that, I'm going to go to my south elevation. From the south elevation, what I want to do here is I'm going to use my Edit Profile tool. To do that, I need to select one of my exterior stacked walls and use Edit Profile. The 2 lines I'm going to draw are going to be vertically on the face of the jog of the slab that you see here, and then horizontally across. And notice I didn't pay attention to where it ended here, because what I want to do is I'm going to draw a dimension to define that height to be 20 foot 8 inches. With these 2 lines drawn, I can use the Trim Extend to Corner tool to create my continuous loop. This is important to have whenever we use the Edit Profile tool, because anytime I'm modifying a profile, I need to make sure I have a continuous boundary, no intersecting lines, and no overlapping lines. Once I'm sure I have that set, I'll finish the sketch and do the same thing on the opposite side, or the west side of the building. I'll select the wall, Edit Profile, And this time I can trace this edge. And following the same steps by using the trim extend to corner, I can create the shape I'm looking for. Now I'll finish the sketch, go to my default 3D view, and take a look at what I've created. In this video, we're going to cover two different types of curtain walls. The curtain wall 1 family type, and we're also going to take a look at the exterior glazing and storefront types and how those differ. And we're going to look at two different methods for drawing these curtain walls. The first one, we're going to use walls that are already created, and we're going to go ahead and change those type to be a curtain wall. For the second method, we're going to draw an embedded curtain wall into the wall that you see here and here. To start, I'm going to select the two walls that are at the entrance to our building here, and I'm going to change their type from what they are generic 6 inches to curtain wall 1. You can see that they change from the generic 6-inch wall to what is essentially 2 glass panels. I'm going to go to the default 3D view, and from here we're going to go ahead and draw in our curtain grids. First thing that we need to do is from the Architecture tab, we're going to find Curtain Grid, and I'm going to allow Revit to do the spacing for me. What that means is I'm going to look across the bottom here, and as I move the mouse around, it'll lock in to certain points, and you can see it's already defining 1/3 of the curtain wall panel for me. And I can do the same thing, and it'll split this one in half. For this side, it'll be a little different. I can go in and I can find the center of the panel, and then I can allow it to divide it up into 4s. For this side, I'm going to put a door within this panel, so I'm going to adjust the dimension of this curtain wall to be 6'2". Now that I have the vertical curtain grids, I can add the horizontals. Using the same curtain grid tool, all I need to do is just find a point that I like. Preferably I'll just place it arbitrarily and then change the dimension. And doing the same thing across the top. And what's nice is once I have it on one side, it'll want to lock in to the other side to keep a continuous line. To create the panel for our door, what I'll use is the Add Remove Segments option. So first thing, I'll select a curtain wall grid, and then pick Add Remove Segments, and select the segment I want to remove. I can do the same thing when creating a curtain grid. Instead of using the All Segments option, which is what we have been using, I can change it to one segment, which will only show one of the segments within here. This grid, I'm going to set to be 8'8" to create the panel for the door. Now that I have all the panels in place, what I could do is I can go in and I can have it, I could use this panel as a door panel. From the type selector, I'll select Door, Curtain Wall, Double Storefront. And depending on my detail level, we may or may not see the hardware. With all the grids placed, I can start adding the mullions now. I'll start with the corner mullion using the 5x5 quad corner. And then I'm going to change from the grid line option to all grid lines, changing it back to the 2.5x5 and adding the mullion to each of our grids. Last thing I have to do here is delete the mullion at the door. And that's how we can manually create a curtain wall using the Curtain Wall 1 tool. Our other option is going to be to use the exterior glazing or storefront to add in a curtain wall that's embedded into our exterior wall. To do that, we'll use the same process, starting with wall, and then we'll select either exterior glazing or storefront. I'll go with exterior glazing. And what I want to do is I want to go immediately into the type properties by hitting edit type. And I'm going to change the vertical grid and the horizontal grid to none, because I don't want those to be automatically drawn in. And if you notice, when we look at the rest of the parameters, you can see vertical and horizontal mullions are set to none. If I change this to storefront, this might be a more desirable option because it's going to draw a lot of the mullions for us. But we would have the same problem with it automatically drawing the vertical and horizontal grids. I'll go ahead and remove those to none. And the important setting we want to make sure is checked is automatically embed. I'll hit OK, and now we're ready to draw our curtain wall. Just like any other wall, we need to make sure our base and top constraint are set correctly. I'm going to draw it from level 1 with the offset of 2'8", and I'm also going to set the top constraint to level 1 as well. And I want my top offset to be 8'8", which will give me a total height of 6 feet. With the top and base constraints set, what I can do now is draw the wall. All I have to do is find the location line within the wall that I would like to draw it on, and I can go in and click the start and draw it along until I get to the end. You can see it automatically embeds the wall. If we look at it in our default 3D view, you can see we now have a curtain wall that's automatically embedded. And from our plan view, I can add my curtain grids at the grid line locations. And you'll notice each time I place one, it drops a mullion in. So I can go back in, and using the same technique we did before, I can add them at the third points between the different grid lines. Once the wall is drawn, I can select it, copy it to clipboard, and I can easily paste it to level 2 to complete my storefront for the south side of the building. In this video, we're going to create and modify a roof that uses the shape editing tools to define the high and the low points. We will modify the roof structure so that the insulation layer is variable in height, and then we'll add spot and slope dimensions to identify the high and low points. The first thing we need to do is create the flat roof. We'll do this from the Architecture tab and create a roof by footprint. For this roof, we're going to make sure we use the steel truss insulation on metal deck with EPDM type. And before we draw it, we want to go ahead and uncheck Define Slope in the options bar. To draw the profile of this roof, I'm going to use the rectangle tool. I'm going to use the inside face of my parapet walls as the defining point. After I have the rectangle created, I can finish the sketch. And from here, with the roof selected, I can use the Add Split Line option to add the split lines that'll define the ridge and the low points of the roof. So the first one I'll add is going to be along grid line 3. And then I want the intersections of grid 4 and B and 2 and B to be my low points. So what I'll do is I'll draw split lines to that intersection. which gives me the low point, as you can see here. And I'll do the same thing on this side. Now to set these points, I can use modify sub-elements, and I can select the point at those grid intersections, and I can give it a positive or a negative value. In this case, we're going to go negative 9 inches. And that's just to give us a slope to these points here. Before we finish this, I'm going to go to Edit Type for the roof type and edit the structure. For layer 2, above the core boundary, I can check variable. And with variable checked, what that's going to do is going to leave everything else flat, and it's going to have this layer slope. So everything above the core boundary, or level 3 here, is going to slope with the roof. The rest of the elements here are going to stay flat. The only thing to keep in mind is that the value you entered, in our case was negative 9 inches, needs to be less than the thickness that we're showing here. So hit OK a couple times. And if we hit escape, that'll take us out of the shape editing mode. And I can go to the 3D view, and you can see that we now have 2 low points in our roof. Going back into my roof plan, from my Annotate tab, I can use the Spot Slope tool, which will identify the slope of my roof. You can see here the ridge has no slope, but our valleys will. And then I can even go in, same thing from the Annotate tab, and I can put a spot elevation either based upon the actual elevation or the bottom elevation of those points. In this case, we're going to use the actual elevation. To define my high point and my low point. In this video, we're going to create ceilings using 2 different methods. The methods we have available to us are automatic ceiling and sketch ceiling. With automatic ceiling, we will set our type from the type selector, pick the offset, and then we can automatically place ceilings within bounded rooms. With sketch ceiling, we're automatically taken into a sketch mode, and we have the same process where I can pick the type of ceiling, but instead of automatically placing it, I need to draw the boundary line. This will be the ceiling for our hallway. And you can see I'm just tracing out the outline. And once I have the continuous boundary with no intersecting or overlapping lines, I can finish the sketch. And it draws a ceiling as well. With the ACT ceilings, a model pattern was applied. And with that model pattern, what we can do is we can adjust it using the Move tool to either have a tile centered or to keep it by default with a grid centered within the room. For the gypsum board ceiling, you may notice that there's not a pattern applied. To apply that pattern, I can go to Edit Type, edit the structure of the ceiling, where you can see that the finish applied is gypsum wallboard. If I select that material and then click the Browse button to go to the material browser, you can see that gypsum wallboard does not have a surface pattern set to it. Now, the best practice here would be to not override this material because it's also probably being applied to some of our walls. So what I'll do is I'll right click, duplicate the material, and I'll add ceiling as the modifier to the end of the name. And from here I can then go ahead and I can add a pattern. In this case I'll use sand dense. And I'll hit OK to get out of the dialog box, and you can see we now have a ceiling placed in our hallway. In this video, we're going to take a look at creating stairs and railings by using the Components tool. From the Architecture tab, I'll select Stair, and what I've done is I've created some guides for myself using reference planes based upon the center of the run. The things that you want to pay attention to when creating stairs is the type you're using, the base level, the top level, and the actual run width that you've selected. Once you have all that figured out, you can start the stair by clicking, and I'll use the helper here to create my first run, which in this case is going to be 10 risers. And then using my reference plane on the other side, I'll go ahead and select the start of the next run, and then using the guide I can select the point of where the stair will terminate. Once I have this created, I can finish the sketch, and you'll notice that handrails are automatically created as part of the stair. I'm going to go to the section view, and from here we're going to adjust the handrail. First thing I want to do is I want to change the type from handrail rectangular to guardrail pipe. This is going to give me the option to modify both the top rail and the handrail independently. For this exercise, we're going to edit the handrail. By hovering over the railing, I can hit Tab, and that'll allow me to select the handrail independently, and then I can hit Edit Type. With Edit Type selected, I can add an extension by selecting the style I want to use. In this case, I'm going to say wall. And then I'll define the length to be 1 foot plus 1 tread depth for the beginning or the bottom. And then for the top extension, I'll do the same thing, set it to wall. And then I can add a length to that as well for 1 foot. I'll hit OK, and you can see the extension is automatically added. If we were to look at this back in the floor plan, you can see that we have railings at the bottom with the extension and at the top as well. We can also edit the path of the railing by selecting it, going to Edit Path, and in this case I don't need the railing to go beyond the run and throughout the landing. So what I'll do is I'll just delete those portions, and you can see this is the only segment I have left, and then I can finish the sketch. Because I've asked it to create a extension at the top, it'll do that automatically. So we'll take a look at that in section, and you can see what we have. The other options for the railing are to have it do a floor transition, which will automatically take a post down to the floor, or a post transition, which will bring it back to the post that's on the guardrail. We're going to stick with wall. When modeling a building in Revit, some situations will come up where you need to provide a shaft or a floor opening through either one floor or multiple floors. First thing we're going to look at is creating a shaft. From the Architecture tab, under Opening Panel, we'll select shaft. The first thing we need to do here is draw the boundary line. To do this, I'm going to pick a rectangle, and I'll draw the rectangle within the space. The second thing I want to do is use a symbolic line to show that this is an open space. By selecting symbolic line, I can now use another drawing method, the line method, to create an X through the opening to show that this is an open space. Once that is finished, then I can go ahead and I can adjust the base offset and the top constraint to set the extents of my shaft opening. I'll finish the edit mode, and then we can take a look at it in section. Here you can see the shaft opening cut through the floor on level 2, but it did not go all the way through the roof. If I were to manually extend that, you can see it will create an opening in the roof as well. Now to create an opening through just one level, what we can do is we can use opening and use the vertical opening option. And this will allow me to only create an opening in the selected object. So I'm using this point here as a reference to select the floor on level 2. But ultimately what I'll do is draw a boundary around the stair. The one limit to these openings is that they have to be within the boundary of the floor or the stair, and that they're only going to go ahead and cut through the object that was selected, unlike the shaft, which will cut any object that it passes through. Now we can see the stair below. If I wanted to refine it further, I could select the boundary using pick lines and adjust the boundary. Looking at it in section, you can see now that the floor has been cut. To create an enlarged plan of an area within a floor plan in Revit, we can use view callouts. View callouts will allow me to have another view that I can adjust the visibility and graphic overrides and the scale to suit the needs of that project. When we look at our starting view, you can see that the room tags take up quite a bit of space within each of these rooms here. But when I add those room tags back in, you can see it's much more reasonable and gives me a lot more space for other documentation. That's because the view scale is different here. You may also notice that the detail level is different in this view as well. That's because that's a view-specific property that I can adjust in my callout view or in my overall plan view. Callout views can also be used for details in section. So if I wanted to add a detail specific to this condition here, I could do a callout. It could be a detail or even a additional wall section. And now I have a detail view for the edge of my floor at that location. I can use the same process to create a wall section for the wall here at grid line A.
In Revit, there are two tools for placing columns, and there are also two categories for columns. On the Architecture ribbon, in the Build panel, there's a column split button. And when you expand the button, you can see the two tools. There's a structural column tool as well as a column architectural tool. I'll open the Visibility Graphic Overrides dialog, and you can see there's a columns category. The columns architectural tool is used to place columns that are in the columns category, or architectural columns. And then when I scroll down, you can see that there's a structural columns category as well. And so the structural columns tool is used to place columns in the structural columns category. All right, I'll click Cancel to close that dialog. And then if we switch to the structure ribbon, you can see that there's a single column tool, or a single column button here, and this is the structural column tool. So on the structure ribbon, just the structural column tool, and then on the architecture ribbon, you get both of those tools. All right, let's start with the structural column tool. And when I activate that tool, you can see that there are several options here. I can place vertical columns or slanted columns, and then I can place structural columns at grid intersections or at architectural columns. So let's start by placing vertical columns at grids. So when I select at grids, I can then select grids, and structural columns will be placed at grid intersections. So for example, I'll use a window and select grids 1 through 5, and then I'll select grid A. And when I do, you can see structural columns are placed, or at least previews are placed at those grid intersections. And I can actually press spacebar to rotate those columns. And then once I'm satisfied with the placement, I can click Finish in the contextual ribbon, and those columns will be placed. I could continue clicking individual points to place columns. In this case, I'm going to click Modify to end the command. Next, I'll open the Level 1 floor plan view, and you can see that the columns are not visible here, and the reason is because of the view range, which is because of the way that the structural columns are placed. So let's take a look at that. So when I select one, you can see that the base level is at level 1, and it has a base offset of -9 feet, and then the top level is at level 1 with no top offset. So let me go ahead and select all of them. I'm just going to use a window to select all of those columns. And let's change the top level to the roof level. And then I will change the base offset to 0. That way they'll go from level 1 up to the roof. So now at this point you can see the structural columns are not visible here in the level 1 framing plan view. But if I switch to the level 1 view, they are visible. And that's just because they are in the view range here in this view, but in this view they are not, because the cut plane in this view is right at 0. Anyways, okay, back to the structural columns here. You can see that they are placed at grid intersections, and which may be what you want. And in some cases, you may want to place them at architectural column locations. So if you're placing architectural columns first, then maybe you want to place structural columns at the architectural column locations. So let's go back to the architecture ribbon, and in the build panel we will select column architectural, and in the type selector I can choose the type that I want to place, and then I can simply click anywhere. So in this case I'll click at a grid intersection, because you can see that there are no options in the contextual ribbon. And when I do, I place an architectural column. Also pay attention to some of the parameters here. I can select for the architectural columns to move with grids, and architectural columns can also be room bounding. All right, I'm going to scroll up here, and just for example, I'll place a bigger column here, and I'm just going to place it here in the middle of the wall, and then click Modify. So one of the cool things about architectural columns is that it will take on the material properties of the element that it is joined to. So in this case, you can see there are multiple layers here within the architectural column, and that's because it's taken on the material properties of this wall. And so just be aware of that. That is a feature that is available for architectural columns. If I go back to this architectural column here, I'll enable thin lines, and we can see it is also taking on the properties of this interior wall. All right, I'm going to place a few more architectural columns here at grid intersections. And then I'll click Modify to end the command. And now let's activate the Structural Column tool again. And this time I'll select at Architectural Columns. And now I can use a window or select them individually and use Control, whatever you need to do to select architectural columns. And then once they are selected, you can click Finish, and structural columns will be placed at the location of the architectural columns. And once again, we're going to need to make adjustments to the base and top levels in our structural columns here so that they will show up in the level 1 floor plan view. And now you can see the structural columns inside the architectural columns.